Okie dokie. 9.4, we will introduce the law of cosines. It appears as though we have a picture here of one of Miss Vanden Heuvel's cats doing their trig homework. Not sure if it's a he or a she, but they're doing their trig homework, and they're wondering for this particular. They're working on this problem, and law of sines isn't working. Okay, what we're after here is to establish the need for the law of cosines. Okay. We're not going to derive the law of cosines, but before we do examples with it, I do want to show you the necessity. Okay, let's say we got this problem right here. We want to find side length x. Okay, that's what we're after. Well, let's go back to 9.3. Let's think law of sines. X over the sine of 125 degrees. Well, that's got to be equal to, let's use side 16 over the sine of, okay, I don't know that angle, but if I knew, oh boy, I was going to use the fact that all three angles have to add up to 180 degrees, but I don't know what the other one is. I know one of them is 125, but the side opposite of 16, not sure. Side opposite of 12, not sure. Remember, if we want to find x, we have to include this ratio right here, and we need to set it equal to a ratio where we have a side length and the angle opposite. Don't have it, don't have it. Okay? Now, if we generalize this case, what we have here is SAS, or side, angle, side. If we have that information about a triangle, the law of sines, which is typically, if we're dealing with non-right triangles, that's our first choice of what to use because it's a little bit easier to use than the law of cosines. So we try that first, but we may find, like this case for SAS, doesn't work. Okay, the way the equation is structured and the information that we have, it just doesn't work. Hence the need for the law of cosines. Okay, here's how I remember both of these forms, and we do need both because one is for side lengths and the others are for finding angles. Just like the law of sines, it revolves around this diagram that has opposite side, opposite angle labeled with the same letter. Angle uppercase, side lowercase. This one is set up to solve for C. That matches the angle that we're taking the cosine of. Okay, and notice the rest of it involves side A and side B. Here, if we're looking for the cosine of A, notice that matches what we're subtracting on the numerator of that equation. Okay, it's the same equation. All that's going on is we've taken this first equation and restructured it to get it solved for the cosine of A, as opposed to being solved for a side length. Okay, that's what they look like. Let's put them to use. Let's solve for side B. Here it is. Okay, now just I think important to point out here. It's the same case that we've had before. SAS, just like the example we started with. Law of sines won't work, so it means we're going to have to go for b squared. Okay, now as far as the right form, remember what this means at the end is I'm going to take the cosine of b. So here I'm going to have a squared plus c squared minus 2ac times the cosine of b. Well, side length A is 8. Side length C is 3. 2 times 8 times 3 times the cosine of 50 degrees. Okay? Now at this stage right here, what I would recommend doing is taking all of this and plugging it into your calculator at once. Okay? Yeah, it would be good practice to get some order of operations work. I don't deny that. That's really what it's about from here, is you've got the whole, notice on the right side of the equation, there are no variables. The only variable we have is already on the left. So most of this involves just evaluating what's on the right, and it's pretty safe here. You can just throw it all in your calculator, type it in number for number, rounding it to the nearest tenth. We'd have 42.1. Here's the one step of solving that we have to do, because we still have to take the square root. And side length B is about 6.5 units. Okay? And as long as you get this first part right up here and you have the right form, it's a big equation and there's a lot to plug in, but it's pretty straightforward stuff. There's nothing too terrible about it. And again, it's important because it takes on this case, this side angle side case that the law of sines can't handle. It will not work. Okay? All right, let's solve. It says to solve the triangle. Here we have a side, side, side case, so the only thing that's missing are angles. All right. Obviously, what we're going for here is to get a little bit of practice with the law of cosines to find angles. Now let's do A first. So cosine of A, remember this is where A will match what we subtract up here. So then it will be A squared plus, should be B squared plus C squared. B squared plus C squared minus A squared over 2BC. Okay, if we're finding cosine of A, this is the only place where angle A shows up. Well, side length B is 10. Side length C is 6. Side length A is 7. And that'll be over 2 times 10 times 6. Okay. Now as a time saver and to reduce the odds that we make a mistake, again, we can evaluate this all at once on our calculator. The one thing we have to remember here with the fraction is when you put this into your calculator, parentheses around the top, parentheses around the bottom. Okay, if you don't, you're going to get something goofy. All right, make sure you remember to do that. If you do, you're pretty good just typing in everything as is. 10 squared plus 6 squared minus 7 squared. All that in parentheses divided by 2 times 10 times 6. And we get 0.725. Okay, and please, please, please at this point don't stop and say, hey, we found angle A. This equation isn't set up to find angle A. It's set up to find angle A's cosine value, which we have, which now means that angle A is going to be equal to the inverse cosine of 0.725, which again is going to come from our calculator, and we see that it's 43.5 degrees. Okay? We're going to solve the whole thing, and we're not far enough along to just say that all three add up to, well, all three angles do add up to 180. But to find the third, we need to know a second. So we have to do another round of trig functions. In this case, the law of cosines. But one thing I want to point out here, I'm going to show you how to do it with the law of cosines again, but I do want to make it clear that if you're looking at this example and saying, hey, wait a minute, if we wanted to find angle B, don't we now have enough information to use the law of sines? And the answer is yes, we do. Okay, and after we get done with the homework assignment for 9.4, where we're just practicing the law of cosines, you would have the flexibility to choose whatever approach you want to take. Okay, if you wanted to use law of sines here, that would be fine. I'm going to show you how to do it with the law of cosines, just because that's the focus of the learning target. And I want you to have several examples in your notes in terms of how to do it. Okay? But keep that in mind. Okay, once we're past 9.4, we get into 9.5, and we do more application questions, you can choose the approach you want to take. All right? Here we would have, as far as the form, this would be a squared plus c squared. The only time side length b should show up is minus b squared on the top over 2ac. And again, this is really the step. Our calculator is going to do most of the work after this. 7 squared plus 6 squared minus 10 squared over 2 times 7 times 6. If we make a mistake with the law of cosines, it usually comes from that step. Something didn't get substituted where it belongs. Something must have gotten put in the wrong spot. Okay? At this point, we have to evaluate that right side, which is just a whole bunch of number crunching, which again, we'll defer to our calculator and let it do most of the dirty work. We get negative 0.179. Okay, and there it should be obvious that that's not the answer, that's not the angle. That is this missing angle's cosine value. The very last step, let's take its inverse. The angle that has a cosine value of negative 0.179 would be 100.3 degrees. Now at this point, we would not need to use the law of cosines a third time to get angle C. 180 degrees minus 100.3 minus 43.5 means this last one is 36.2 degrees. Anytime you're able to use that element of triangles, you can. Okay, that's certainly acceptable to do that. Okay, so there's 2 examples of how to find angles with the law of cosines. A little area problem that I'm not going to work through the whole thing, but to get you going on this one, because I think this is a great place to finish, is a problem where before you get to your homework problems, to kind of verify to yourself that, hey, I can do a little bit of this on my own. It's an area question. Okay, I'm gonna give you the overall strategy, a few pointers on how to take this one on, and then leave it up to you. Okay. The biggest thing I would do here is I would decompose this down into 2 triangles, triangle 1 and triangle 2. Okay, with our strategy being that the total area is the area of triangle 1 plus the area of triangle 2. Okay, so from this point, what we would do is say, all right, this is 2 completely separate problems. We have triangle 1, we have triangle 2, and we are going to focus on finding their area separately. And all we're going to do at the end, and in fact, let's leave a little room down at the bottom of our problem here. We'll cut off our work right here, for area 1 plus area 2. Okay? Now what we should be thinking, and I know it's been a little while, but area of a triangle, we have 2 options. We have 1/2 base times height. Okay? That's not going to work here. We don't have the height of either one of these triangles. The other alternate formula we came up with was 1/2 AB sine C. We should be thinking of using this formula for both of these triangles. But remember, it requires that we know side angle side. Okay, we have to have 2 sides and an angle in between. Now, for triangle number 1, it's a pretty straightforward case because we look at this triangle, which I'll highlight all of it in blue. We know we have side angle side. AB is 10, AC is 10, angle B is 132. 1/2 times 10 times 10 times the sine of 132. Okay? 1's a pretty straightforward case. Now, let's look at 2. Here's what I know about triangle number 2. Okay? I know that this side right here, AD, is 12. That's about all I know. Okay, my guess is that it's going to be best to try to use this info right here to get the side angle side. But I don't know theta. Let's call that the angle in between. And then side length B, the other side for the SAS component. I don't have that either. Okay, that's what triangle 1 was a pretty simple case because I had all the information. I have one of the three things. Okay, I have one of the three. Now this is the point where I want to throw it over to you. Okay, with really one other thing. This first triangle is isosceles. Whatever angle this is, this other one's the same. Okay, that's a piece of information I think a lot of people might have missed. Okay, that's going to be the same. And where you want to take a look at this one is how do we find side length B? Okay, triangle 1 had more information, so you're likely going to use that. And remember, this is under the learning target for Law of Cosines. Hint, hint. Law of Cosines may be the key to getting side length B. And then the fact that these two angles, you know, are the same because this triangle 1 is isosceles. Okay? Give that a shot. Remember, it's eventually coming back to this area formula if you can get that SAS situation. But see if you can take this one from here. If you can handle this problem, you would know going into the homework assignment, you should be good on most of them. Okay? Good luck with the rest of that problem. If you get stuck on anything, okay, in class we can go through the entire solution from here all the way to the finish. All right? Best of luck on this problem and the homework, and we will talk more in class.